So let's do an example of a cube of charge. So let's say we have a cube. Every charge on the cube is going to be the same charge. So we got a cube here. So every charge is going to be the same. So each charge is going to be the same, okay? And each side length is going to be the same. So the side length is A. And so I want to know what is the total energy it takes to assemble that cube. Okay, so we look at it and say, well, we know that the energy here is going to be Q times V. Well, all we got to do is find the pairs and add them all up. So we got we got between each side. So each edge, okay, is going to have U equals KQ squared over A. Okay, how many edges are there? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 of the edges. Then we have a body, rather a face diagonal. Okay, so that length across that face right there, that length, the R is going to be square root of 2A if you do just a little bit of geometry there. So that means that the energy is going to be KQ squared over square root of 2A. How many of those are there? Well, each face has 2. There's 6 faces, so there's 12 of those. And then we have a body diagonal across the width of the entire thing. Okay, so we have a body diagonal. So we want to find out, well, how long is that length right there? And so you say, well, that's the length of that is going to be, well, Pythagorean theorem, we know that's square root of 2, then that's going to be that. So it's going to be the square root of 2 times A squared plus A squared. So that's square root of 3A. So that means the energy is going to be KQ squared over square root of 3A. There are 4 body diagonals. So the total energy is going to be 12 times KQ squared over A plus 12 KQ squared over square root of 2A plus 4 KQ squared over square root of 3A. Okay, and so you multiply all that out and add it all up, and that comes to be about 23 KQ squared over A. So that's the total energy that it takes to assemble that cube of charges.